Welcome everybody to the March 2026 MAS monthly meeting. I am Walt Straybergs, your MAS president, and we have a slightly abbreviated program today because we've got actually 3 speakers. I've cut out a lot of the regular PSA slides that we normally do. We'll go through a welcome. We will do a brief treasurer's report. Noha is not here I don't know if she's online, but we can go through the treasurer's report, membership update, Astro events for the month, outreach requests, and the upcoming MAS events as it's March and we're going to be kicking off our observing season really soon, in a matter of days and weeks. And then we will have a slight presentation from Gordon Baustian from the Cedar area astronomers, and because they are hosting the NCRAL regional event, and so they wanted to dial in and give us a little update, 10-minute update on that. We'll go through volunteer opportunities, and then we have a member presentation by our very own member, Greg Hallberg, about planetary seismology. And then our very own David Falkner will be talking about Stonehenge as the key term. Stonehenge. All right, here's our board. A few of us are not here. Noah's not in the room, but Jesse is here. Phil is here. Claire, I believe, is at home. And John, and I'm here, of course. Any questions to the board, you can always contact us through the website, mnastro.org. About board contacts, there's a form you can fill out, and you can contact any one of us. Sorry for my voice. I had a long day. I woke up at 4 o'clock this morning in Phoenix, Arizona. So new and returning members, whole slew of them this month. Allison, Michael, Brandon, Ann, Matthew, Anita, Anna, Dennis, Eric, Kachub, Dan, Kamala, Brendan, Michael. Any new members online or in the room? All right. If there's anyone online, you can unmute yourself and say hello. So we've got 692 total members, so we're continuing to hover around that 700 mark. 3 honorary, 152 patron, 511 regular, 26 student, and this was as of the beginning of the month. So questions about membership or any of the perks and benefits for membership or just anything in membership in general, you can send Steve an email at membership@mnastro.org and get your questions answered. All right, Astro events. March 2026, March 6th, conjunction of Eris and Ceres. Let's see how that one goes. Conjunction of Venus and Neptune on the 7th. March 8th, conjunction of Venus and Saturn. Okay, it's the big line of planets, right? Third quarter moon, March 11th. Conjunction of Mars and Mercury, March 14th. The Gamma Normid meteor shower. I'm not going to hold my breath on that one. The conjunction of Moon, Mercury, and Mars on the 17th. New moon on the 18th. Equinox on the 20th. So definitely spring is knocking at the door. Asteroid Massalia is at opposition on the 21st. Close approach of Moon and M45 on the 23rd. Mercury's highest altitude in the morning sky on the 25th for this go around. March 26th, conjunction of the Moon and Jupiter. First quarter moon, March 25th. March 27th, close approach Moon and M44. Full moon on April 1st. And as a bonus, Makemake is at opposition. So with the full moon, by the way. So Mag 17, let's go for it.
You got the dreaded switch to daylight savings time.
Oh, yeah. Let's just ditch that and just move on. All right. Couple Couple comments that we need to keep track on. So C 2026A1, the Kreutz sun grazer, which is still a potential flare-up in April. I don't know, what, is there any still possibility? It's, if it survives, the,
They don't think small.
yeah. Okay. So Suresh says that the percentage of survival might have gone up a little bit. Also, C 2025 R3 Pan-STARRS, peak brightness April 16th. So that's another one to keep coming up. Kind of been a surprise. And 2024 E1 Weirkos, I think you imaged that, right? Not yet? Okay. Yeah. So that one's still, those are the bright ones in the upcoming month here, couple months. So space time. So jealous because Steve saw the ULA rocket go up last month and sort of more or less be successful, but it blew its nozzle off, but it still worked. It made it to orbit. So there is a possibility SpaceX Starship Flight 12 is they're threatening to maybe try that. They're doing their final pressure tests and doing their final things there with the new pad and the new version 3 Starship. But who knows? Blue Origin still slated to fly the booster, the same booster that they caught that landed on the ship the last time, sometime in March. Artemis, that's who knows. It's looking better now, but it's probably not going to be until April. I'm guessing not going to be April. It hasn't rolled out to the pad yet, has it? Back out to the pads? It's still in the VAV, yeah. And then there's some interesting rockets out of China. So Kinetica 2 is a cargo, as a new reusable cargo vessel going to the China space station and with a reusable booster. So they're going to try to land that booster. And then Progress, the Roscosmos Progress Soyuz MS-33 to the ISS is going to deliver cargo. So that's what's coming up in the next step. Yep. Oh yeah, we could that could be a whole lecture right there. The whole Artemis. Dave's got to redo his lecture on Artemis now. Yeah, now Artemis 3 is not going to be the moon landing. Artemis 3 is going to be a Earth orbiting, just a trial. They're going to test docking all the different systems, but they're not going to go to the moon. But Artemis 2 is still going to do a free return around the moon. So yes, yeah. New Shepard is well, they put it on pause, but basically it's done. Yeah. Yeah. All right. So sources for all this is in the sky.org for the sky events. It's really good. The nice thing about the in the sky is if it says something about a conjunction or a occultation, you can click on it and it tells you right there whether you can see it or not from your local location. So it's a really nice tool. It gives you a map of where on Earth it can actually be seen. All right. Outreach requests. Got a bunch coming in. There's a optional one. People are requesting a daytime school field trip at ELO, just to see an observatory. Looks like middle schoolers. February 26th, March 4th, St. Paul Middle School Star Party, Global Arts plus Upper. April 18th, Camp Filippo down south. July 14th, 16th, ELO Baylor Adventure Camp. August 12th, Able Park, St. Louis Park, not St. Louis Park. And there's other opportunities that are later in the year that are coming in. So if you want to volunteer, just look at the outreach forum or on Slack pages and sign up for those outreach events. They're fun. And Jesse will hook you up with the right people and coordinate the event. So thank you, volunteers, for that. Also outreach, we're still looking for outreach committee people. If you want to be a little more active on the planning of the outreach and working on improving the outreach, Jesse's would love some help.
There, real quick.
Yep.
That's been canceled. They decided to go another direction.
Okay.
If they're gonna try to bring
Oh, okay.
venture camp that they're doing in July. I'm trying to work with them to find a date that will actually be cloud free that we can do it. So what I'm looking for is a few folks that can come out during the day on 14th, 15th, or 16th of July to do the tours and solar observing with the youth that are at the adventure camp.
Okay, and then, yeah, just let's put that information on the forum, so it's all clear to everybody, so you know what's signing up and all that stuff. Well, thanks, Don. All right, beginners special interest group. We have one more Zoom presentation, and this will be done by our own Ahmed. And I don't think he's started his presentation yet, so I'm guessing it's going to have something to do with medieval Islamic astronomy, but I could be wrong. So watch the calendar at mnastro.org for updates and link to the Zoom for the event. It's March 28th at 1 p.m. And then it gets recorded and put on the YouTube channel later. All right, MAS events, things are starting to heat up. So March 13th through the 15th is the first LLCC observing weekend. That's at least on the calendar. But make sure you're following the forum, because the March events are most likely going to be canceled if the field is too wet or it's too cold or it's icy and there's snow on the field. So it's probably not going to happen. So it's really important that you follow and sign up on the forum, and we'll advise you whether it's a go or no go. So March 14th is the first ELO Public Star Party. Do you have a speaker, Don, for that? Is there a speaker?
Yeah.
All right, awesome. So we will have a speaker for March 14th. And then March 14th, also, there'll be a star party at Cherry Grove. The next following weekend is also another LLCC member weekend, observing weekend. And then March 21st will be the first public star party at Cedar Creek. So those are always fun. March 28th, again, will be on a Zoom presentation. April 2nd will be the monthly meeting here and on Zoom. And April 11th, we will have our first new member orientation meeting of the year. So that's a little bit farther in, but into April. And Rebecca is going to be running that. She's already preparing her slides for that. Key holder training. So I finally got some dates for all the sites for key holders. So ELO, the first available key holder dates will be April 11th and May 8th. There'll be you're still using the website sign up form, I assume. Yep, just as it was last year. JJC, April 4th and May 30th will be key holder training, and that is signing up on the forum for CASB. And then CGO, March 14th and May 15th. And then at LLCC, the official training happens during NNSF in September, or by special request and basically mentoring with another committee member in advance, just arranging it in advance. All right, that's key holder training. So we have two big events. So Northern Nights Starfest, September 9th through the 14th. Registration is open. So this is the link to the calendar, and on the calendar it goes to the LLCC site for registration, the Camp Brain LLCC or Long Lake Camp Brain, or I forgot what the link is. But that's always a fun event. So again, it's September of this year. So 9 through the 14th. And we're also looking for speakers for Northern Nights. So Camping with the Stars at ELO, August 14th through the 16th. I checked the Carver Parks website, and they are taking reservations, and they're selling tickets already for that. So, and you can get to that through the link in the calendar for Camping with the Stars. So those are our big events. Registrations are open. All right, I would like to introduce Gordon Baustian. So Gordon, if you are online, and I hope you are, I didn't check, you can please take over. And if you have your little presentation ready, we'd be happy to hear all about Eastern Iowa Cosmic Conference. Well, okay. We'll keep an eye on Gordon. Maybe we can squeeze him in a little bit later. So I talked to, or Jerry texted me, there's no awards this month. He still thinks we're a bunch of losers. So that's Jerry's words. I can show you the text. And then, hey, T Corona Borealis Challenge is still there. Any day now. We did get a notice from the Astronomical League that there has been some hacking attempts. There's been some phishing using some of the officers of the Astronomical League. So if you get anything from the Astronomical League, especially from Chuck Allen, something that has something about money, it's almost certainly phishing. They sent out a notice to all the clubs that just to keep an eye out for things, by the way. And since Jerry is not here, let's see if this works. We always love virtual Jerry.
Get out there and observe or image.
There you go.
Get out there and observe
One more
or
time.
image.
All right. Volunteering. Ways we really, the whole club really runs on our volunteers. So the best ways to volunteer for MAS is basically join a committee, do a presentation. Father Brown, as we've been publishing a couple of desperation emails and pleads for articles for the Gemini. Always always can write and contribute articles to Gemini. Contribute ways on a web team, or join a committee, like I said, help out at a public star party, become a key holder, become a active star party helper, ELO, Cedar Creek, BSIG, JJC, and then as always doing outreach. So from the committees at this point in time, as I mentioned before, outreach committee is looking for some help. We've got, I believe, 2 committee openings at Eagle Lake Observatory. We want to expand the committees a little bit. We've been expanding all of the committees just to get more volunteers going and trained to sustain the club over a longer term. And we also will be establishing a grant committee. So the grant committee will be, Noha will be not necessarily leading that committee, but she will be participating in that committee. And the goal is to, for special designated projects that the club wants to do, whether it's purchase a new acquisition, acquire a new piece of equipment, or maybe even build an observatory or do something else, that we actually put together some documents and send out requests for grants. It's been very successful in Iowa, and we think that we have the resources and the membership to be able to do that here. So those are opportunities that we have. If you want to participate, contact any board member or contact the committee that you want to help out, or if you just want to send it by email, you can send it to info@mnastro.org, and I get that email and I will route it to the appropriate person. Thanks. All right. I would like to introduce Greg Hallberg. He is a member and he's going to talk about planetary seismology.
All right, everybody. Good evening. Obviously, I'm Greg. Been a member a couple of years. In all honesty, my objective was to kind of lay low, see what the membership is all about, see what your presentations are like, the content, guest speakers, and just get some sense of maybe what's appropriate, what the membership might enjoy or not. So anyway, tonight's little talk vignette is about planetary seismology. There's an awful lot going on out in the solar system. Okay, I'll get this. A lot of times people think about the solar system as sort of quiet, dark, in this vacuum of space, just a lot of nothingness out there. But in fact, there's an awful lot going on. It's shimmying, shaking, gurgling, doing all kinds of things. The best way for the scientific community to understand or to begin to research, quantify, measure what's going on in the solar system would be through geophysics, geophysical science, geochemistry, obviously the science of seismology, more specifically in my wheelhouse, planetary seismology, some of the current research that's going on. So basically, geophysics, and that's what I do for a living, is application of physics to study the Earth's properties, the processes surrounding space, investigating the planet's deep interior, magnetic fields, atmosphere, even other planets. The primary quantitative methods and tools would be analyzing data from seismic waves, gravity, obviously magnetism, electromagnetic fields, methodology, something called geodesy. We'll talk about that in a second. Satellite geophysics use electrical currents or electromagnetic waves to image subsurface conditions. Oceanography, atmospheric science also involved. The physics to study the oceans, currents, climate, atmospheric phenomenon. It's all rolled into a body of knowledge that we consider the optimum way to explore the universe, for that matter. One component is geochemistry. Geochemistry is pretty straightforward. Composition, structure, processes of the Earth, of other planets. Investigate the distribution of elements in the geosphere, the rocks, soil, what makes up our Earth, hydrosphere, all of the water, the oceans, the lakes, so forth. Atmosphere, biosphere would be obviously all living, breathing plant life, animals, and so forth. How the energy cycle works through rocks, soil, water, gases, examining the Earth's composition materials. And through all of that, we can better understand the structure of the Earth, the dynamics of what's going on with the Earth, the evolution of the Earth, the origins of the Earth. We can date rocks through the chemistry, tracing sources, obviously fossil fuels, carbon cycle, and even analyzing meteorites, other planets, to understand the solar system's origin. Solar system planets composition, we think about when we're going beyond Mother Earth. Mercury, Venus, Earth, Mars are basically rock, silicate rock, okay? Predominantly iron and nickel. Jupiter and Saturn, as you all know, are the gas giants. Hydrogen, helium make up their primary composition. The ice giants, Uranus and Neptune. Water, ammonia, methane, ices. In geodesy, and I'm not going to go through all of this because it gets kind of tedious and I'm watching the clock. Geodesy is basically understanding the size of the Earth, where we are in the solar system, how we rotate, our gravity, various atmospheric conditions that make up how the Earth functions. It's a mathematical discipline which measures precisely the Earth's size, shape, as I said, orientation in space. It'll change over time. There are techniques within geodesy that have been created, notably GPS, modern navigation, satellite tracking, lasers that have been used into deep space. Okay, cut to the chase. Do other planets have earthquakes and volcanoes? Yeah, they do. In some cases, we've been able to directly measure earthquakes, volcanoes erupting. Earthquakes on the moon and Mars are referred to as moonquakes, Marsquakes. The Apollo program, the Lunar Surface Experiment Package, the ALSEP on Apollo 14 and 16, the astronauts unpacked and put probes into the ground, activated a charge to see what's going on with the Earth's crust, the Earth's surface, see if they could develop, if you will, listening devices for lunar activity. They even had a mortar that they unpacked from the lunar excursion vehicle to shoot off to see if they could get more of a pronounced explosion from a distance. And they succeeded. There were other passive seismic experiments that are still going on, that are just quietly listening for vibrations, movement in the lunar interior, and impact from meteoroids. Seismic experiments' purpose to determine the internal structure, meaning the thickness of the core, the mantle, the crust, the composition of the moon, forces that were deforming the moon, the number of meteoroids hitting the lunar surface. And that all played into studying the same phenomenon, the same anomalies in other planetary research. Obviously, the next place was Mars. Seismometer put on Mars as part of the InSight mission. I'll show you a photo of that later. It landed in 2018. Course of the mission, InSight measured Marsquakes caused by impact events, as well as motions in the planet's interior by movement of magma and shrinking of the planet. Interestingly enough, in total, the instrument measured 1,319 Marsquakes. The largest Marsquake was a magnitude 5, which occurred in May 2022. You know, on the moon, the best one they got was about 5.5. That would cause property damage on Earth, so moderately severe. All of the large Marsquakes originated in an area called Cerebus Fossae, which is associated with relatively fresh lava flows. They intentionally wanted to execute probes and a better understanding in that region. Even when we don't have seismometers on other planets, we can actually tell that some worlds do have earthquakes. Talk about them in a second. We can look at the past through satellite observations. There are cracks in the surface, a clear giveaway that some sort of thumping is going on. Cracked rocks, same thing on Enceladus, Europa. We know that there were quakes from those cracks. Quakes of all sizes are interesting. They tell us a lot about the inside of a planet, not just the outside. The moon, for example, has a smaller liquid core surrounding a solid core. Mars, on the other hand, is substantially larger than we thought. Okay, to me, this is the fun part. This is the good one. Volcanoes. We see volcanoes of various sizes and shapes on most every planetary body. You can see them up there. Mercury, Venus, Earth, Mars, Ceres, Europa, Ganymede, etc. Each of them possess, through observations, volcanic landforms, typically in the form of volcanoes or volcanic flows. The magma associated with the volcanoes on icy moons, like Enceladus, is icy water. ammonia, methane gas. So we call that process cryovolcanism. Volcanoes are not only features that indicate volcanic activity, we look for the lava flows. We look for any other evidence of what's going on. Cryovolcanism, it's a volcanic-like activity on a celestial body, moons and dwarf planets, that erupts volatiles. Like I said a minute ago, water, ammonia, methane, instead of molten rock. They get a lot of geysers. In a second, I'll show you a photo of Enceladus, one of Jupiter's moons, with a lot of geysers spouting. It's really pretty cool. Instead of silicate magma, cryovolcanoes erupt liquid mixtures, as we've talked about. Normally, when you think about the Earth, or particularly the moon, you're talking about tidal heating from the gravitational pull of the planet from Earth, for example, on the moon. The moon does not have tectonic plate shifting like we have here on Earth, but the moon has tidal waves, subsurface tidal waves that create part of the dynamo effect, that constantly churning effect, which activates an electrical current, which activates a magnetic force, and that's how the planets basically generate their magnetism. One of my favorites for years has been Io. Sorry, there's an L, there's a typo there. Io is a large volcanic active moon, sort of butterscotch yellow in color. It's a moon of Jupiter, not a planet itself. It's the innermost planet of the 4 Galilean moons, most geologically active body in the entire solar system, with over 400 active volcanoes. It orbits the giant gas planet Jupiter. Defining feature is extreme volcanism and all of that intense tidal heating that I referred to. Gravitational force from Jupiter and its neighboring moons, Europa, Ganymede, constantly squeeze and stretch Io, generating immense internal friction that heats up the interior. There's a picture of Io. Unlike most moons in the outer solar system, which are composed primarily of water and ice, this is silicate rock, molten iron, and a molten iron sulfide core. Bodies that are not rock solid like metal and icy moons and dwarf planets experience seismic activity quakes just the same from internal geological processes. Again, could be tidal heating, could be a freezing and thawing cycle, or even external impacts. Gas giants have an internal shift. Moons such as Europa, which is icy, Pluto, rocky and ice, show signs of seismic events. They've got the cracked surfaces. They exhibit the same cryovolcanism, proving vibrations occur even in non-rocky worlds from tidal stresses or mantle convection. The convection obviously is the heat transfer even that we experience on Earth. Warm inner core, colder, warm goes up, cools down, the cycle continues, and you get that dynamo effect, and that's basically what creates our electromagnetic fields. Largest volcanic eruption ever seen on Jupiter's moon, Io. There were simultaneous eruptions, over 400, over an area of 40,400 square miles. They're still having a little bit of difficult time analyzing the data, but it does suggest that the entire energy expenditure was between 140 and 260 terawatts. A terawatt is a trillion watts. It was just December 27th, 2024. Juno spacecraft was at 46,000 miles, observed the volcanoes. The previous best was 80 terawatts. Mount St. Helens in 1980 was 52. So there's a lot of thumping going on out there. Again, this gets a little tedious, so I won't go all through all of this, but in the upper right, it explains tidal forces, the gravitational tugging, pulling, squeezing, give and take, the flexing, internal convection, heat and pressure changes, and obviously impacts, asteroid hits, all have a remarkable effect on the bodies, heavenly bodies, celestial bodies involved. These are the ones that we're spending the most time looking at right now. Obviously, Europa, icy, shows cracked surfaces. Ice moon, Enceladus, I'll show you that in a second. A lot of cracked surfaces, water, freezing, shifting. It's got a huge, enormous amount, an ocean-like amount of water below the surface. And when it pops, you get these geysers of astronomical proportions. Gas giant moon, Io, volcanically hyperactive. Immense tidal forces that are creating massive quakes. Starting to sum up current planetary research, seismology research is for the most part present day focused on analyzing data from past and ongoing missions to Mars and to the moon. This happens to be one of the stationary probes on Mars, InSight. It's not moving around, for example, like Perseverance, digging and sending back signals. It's right there, it's drilling, it's analyzing all the bumping and grinding that's going on at and below the Martian surface. A lot of advanced computational modeling is involved to understand the internal structure, evolution of solid planets. Apollo missions, very helpful back then, still very helpful now, and they're still analyzing the data. These are the planetary moons of interest. The moons, of course, the two moons that Mars has, Jupiter, the primary ones, Saturn and Jupiter have got close to 100 moons. What is it? Saturn has like 241 moons, I believe. Uranus, Neptune, Triton does a lot of seismic activity, but it's way out there, and we don't have a lot of capabilities yet to see what's going on day-to-day real time. General research, everybody's interested in the icy satellites in Venus. Seismological laboratories, including the one at Caltech, are involved in proposed missions to Venus and the icy satellites, and Saturn's moon Enceladus has a lot of interest in the planetary science community. Asteroid properties, we're all familiar with that. Geophysicists are using radar observations, numerical simulations to understand the physical properties and the internal structures of asteroids. Obviously, technological advancements. Where would we be without AI? Almost done. Kaolinite is a mineral typically found in hot, humid, moist environments. Perseverance found a ton of it on Mars. It's one of the best smoking gun pieces of evidence that Mars did, in fact, have at least half of the surface covered in water, somewhere in the neighborhood of 1 billion years ago. It's kind of a light yellow. They call it china clay. It's used in ceramics, porcelains, paper. To touch it, it has sort of a waxy, greasy feel, sort of soft, on the Mohs scale, MOHS, when we're talking about moon rocks, I'm a rocks guy. Analyzing things moon or otherwise related. The Mohs scale basically goes from under 1 to 10. A diamond would be 10. This sort of stuff, a lot of the minerals that we see, 2.4, 2.8, 4.0 maybe. You all know about the categories of rocks, Geology 101, igneous rocks, cooling, lava, sedimentary rocks, layer on layer, metamorphic, involved with a lot of pressure. Granite, basalt would be igneous, sandstone, limestone, shale, sedimentary, marble, slate, and one called gneiss that I highlighted. This happens to be a picture of gneiss. It's used primarily in architectural construction and road grading in this world of ours, but they're also finding it of all places on the moon surface. And wrapping up, lunar geology. Moon rocks are mainly silicate minerals: oxygen, magnesium, calcium, iron, aluminum, titanium. Titanium plays a very big role in the generation of the moon's electromagnetic field, albeit somewhat small. Some of the others that are there are formed by igneous activity. Most everything on the moon is igneous. It lacks water and contains no sedimentary rocks, as they're formed in the total, almost near total absence of weathering. Even moon dust. Moon dust, people say, well, why is moon dust so dangerous to breathe in? It's razor sharp. Even the dust particles under magnification are very pointed, very rough. There's no atmosphere, there's no wind, there's no weathering. So moon dust doesn't erode, it doesn't grind smooth. That's one of the reasons that it's so difficult to handle. Okay, an acknowledgement of some of the resources that I've used for this. I've had the chance to work at a couple of these places, work with some of these folks, and it's been a good ride. Thank you.
Does anyone have any questions? Here.
I've got two questions.
Sure.
First question is, have you been able to detect earthquakes caused along a terminator line, especially like a Mars, where it's real hot on one side, real cold on the other side? Any kind of seismic activity along that?
Absolutely. An abundance of it. Even from remote stations and from satellite observations, they've been able to detect that is in fact the case.
Also, do you study solar quakes?
I study in my scientific background, a lot of what I do, a lot of what I do relative to that would be solar flares, the influence that solar flares have on radiation, magnetic fields. When the space shuttle goes up, when the astronauts went up, there was a lot of concern, for example, about the Apollo astronauts traversing the Van Allen belt. Everybody know what that is? James Van Allen, 1958. But they passed through it so quickly that it wasn't a problem. I don't know if I answered your question. No, the short answer is not much.
All right, thanks. Thank you, Greg. All right, I do believe Gordon is online from Iowa. So Gordon, if you want to unmute, and I will stop my sharing, and if you want to take over the screen, you are welcome to do that at any time. Whenever you're ready, you can take over.
All right, can you hear me okay?
Yes.
Okay, let me share my screen here real quick. Alrighty. There we go. Okie dokie. And I'm hoping everybody can see everything now. So can you see everything?
Yep.
Good. Okay. Well, thank you. My name is Gordon Bastian. I'm one of the members of the Cedar Amateur Astronomers here in Cedar Rapids, Iowa. I'm also a vice president this year of the organization, and I'm one of the people on the planning committee for NCRAL 2026. We're calling this the Eastern Iowa Cosmic Conference. And this year it's going to be here Friday, May 15th through Sunday, May 17th here in Cedar Rapids. Now, the Eastern Iowa Cosmic Conference is really three distinct events. First, we're going to have track one, which is the actual NCRAL annual conference and meetings. We're going to have track two for, as far as we know, it's the first time that we've ever had in conjunction with NCRAL a public area. So we were trying to get people to come down, see what astronomy is all about. We're going to have all these very interesting exhibits and presenters. Also, earlier in October, actually, I found out about this Harlow Shapley program for lectures that's sponsored by the American Astronomical Society. And I read about it and found out, wow, that's just exactly what we're doing. I applied for it, and we were notified in December that we were selected for a Harlow Shapley program lecture that we're going to be having here, and they sponsor it, and it's for free. So all the very formal programs start on Saturday. However, on the Friday evening of the 15th, we're having an informal event at our Eastern Iowa Observatory and Learning Center, our observatory. And then the Saturday, we're having the formal programs. That'll include the NCRAL business meeting and elections. And then we'll have our plenary sessions. We'll have our Saturday evening conference banquet and our keynote address. And then during these times, we'll have our astrophotography contest. We'll have the NCRAL and the Astronomical League Awards. And then Sunday, we'll wrap up with some optional tours that will include the Collins Aerospace Museum, the Astronomical Clock Tower at the Czech and Slovak Museum here. It's called an Orloj. And then a visit to the National Radio Astronomy Observatory site. And then the University of Iowa Van Allen Space Flight Laboratory. So in more detail here on Friday evening, at the observatory, we're going to show people around, show them our instruments. We're going to have a catered meal that's included in the registration. We'll show off our exhibits, have time for networking and informal talking. Plus, we're going to have some fun activities with trivia and contests, as well as laser pointers and drone photos. We'll also have a few things if anybody wants to swap or bring. And then, weather permitting, night viewing. On Saturday, our conference, or formal conference, really takes off downtown at the Doubletree Hotel and Convention Complex, a very nice facility that will really meet our needs. We have a very impressive lineup of speakers. As I was talking about earlier, our Harlow Shapley lecturer is Dr. Ryan French. He's coming to us from the Laboratory for Atmospheric and Space Physics in Boulder, Colorado. His area of expertise is what he calls solar explosions. He did his undergraduate and PhD training in England. He's been involved with a lot of media, CNN, Fox Weather Channel. He's written 2 books, and I'm told the third is almost ready for publication as well. We've had the opportunity to speak with him a couple of times. Very dynamic guy, really nice. I feel very lucky that he's our lecturer. For our session, he's going to talk about how to live under a star. Next, we're going to have Dr. Halikas from the University of Iowa. Jasper was involved with the development and some of the instrumentation on the Parker Solar Probe, and when he was at UC Berkeley. And he's continuing his work with the Parker Solar Probe at the University of Iowa. Following him, we'll have Dr. Allison James from the University of Iowa, who's going to talk to us about the Nature's Light Show, the physics of aurora. Then we'll have Dr. Charles Curtin from Iowa State University. He's going to talk about stars forming stars, fact or fiction. And then we'll have Charlotte Christensen from Grinnell College. And I think she's got a very interesting title here of her talk. I'll be kind of anxious to hear her talk, but it's the proper care and keeping of galaxies. Then finally, I think is the most intriguing talk Sean Walker is an editor actually from Sky and Telescope magazine, which is a really interesting project he's been doing. He and two of his colleagues started doing a hydrogen alpha survey of the entire night sky. I believe this started in 2016. Unfortunately, one of his colleagues passed away of cancer, but the work continues. And it should be very interesting because I'm very excited because here's an amateur talking to amateurs, and I think it's a real tribute to the citizen scientists and what they can do and contribute to the field. On Sunday, we were talking about some of the tours. Collins Aerospace Museum. Arthur Collins was the founder of Collins Radio and all his instrumentation that went to the moon and have very large presence, and now it's Collins Aerospace. Also, the astronomical clock tower, or Orloj, at the National Czech and Slovak Museum, we're going to visit. It's the only one like it in North America, and it's modeled and actually was built by the same people and engineers who built the one in Prague. Then we get to visit the National Radio Astronomy site. Very few people know we have this little gem heading out in the woods around Coralville Lake, just to the south of Cedar Rapids. And this our site is part of the very long based array out of Socorro, New Mexico. So, you know, it's very cool. You know, people talk about seeing all those radio telescopes in that movie Contact years ago, but yeah, it's really neat. You know, like I said, this thing's just hidden out there, and if you didn't know it, you'd drive right by it, and it's really interesting to see this 250-ton thing move on a dime. And it should be, it's not very often you get to go up close and personal to a radio telescope. And then we're arranged for a tour of the Van Allen Space Flight Laboratory at the University of Iowa. So I think those should be pretty fun. On our website, we had such a strong response to these tours that we kind of had to tell people, hey, we may not be able to get everybody in on a tour, but please sign up so we can gauge interest and we can plan the logistics and how many groups we have to have. It may be that we'll have to give priority to those folks who are from out of town. So we'll just have to see. But again, we've had a very strong interest and reaction initially here. So I just want to give a big shout of thanks to our partners. We clearly couldn't do this by ourselves. Then just a couple of sentences here about Cedar Rapids. We're a very warm and welcoming community. Typically, it's pretty nice here in the spring. We have deep connections to astronomy and aerospace industries, very technologically advanced employment opportunities here, exceptional educational institutions and program, and we offer a diverse range of dining, culture, and fine arts and recreation. So in summary, please go visit our website. It's pretty easy to remember. It's just ncrawl2026.org. There's a registration information, detailed agenda and timelines, speaker CVs and topics, banquet choices, more information about the Harlow Shapley Lecture Program, our sponsors or donors, and more information about Track 2. And the reason I mention that is because oftentimes if you bring your family or children with you, they get orphaned while you're at Track 1. They can certainly go to Track 2 and enjoy a lot of the other venues. Also, there's a very long FAQ there and much more detail. So save the date and plan to come down from Minnesota, and you can bring your swimsuit and get your suntan in the warm weather in Iowa. But save those dates for May 15th, 16th, 17th of 2026 coming up here very shortly. So I'm happy to address any questions if anybody has any.
I just want to add a couple of things here. The Track 2, we have some of our amazing solar system ambassadors that are going to be down there. I know Trina and Dave Falkner are going to be down there for that. So that's exciting. The other thing is the information, some of the information for this is included in the happenings that Clear sends every week, like on Tuesdays. So if you did not take a note of the website, go back and look at the happenings and you'll find the information there.
Thank you, Noah.
All right, any other questions? All right, I guess not. So thanks for all the information. It sounds like a really good, well-organized event, and we'll see if how many people can actually make it, and we'll see. You
Yeah,
know, it
maybe
sounds really fun.
Yeah, maybe get a Greyhound bus and come on down,
An idea.
Yeah, we're really excited. We got this really strong lineup. We're very fortunate. We've had Dr. Steve Spangler, who's a professor emeritus from the University of Iowa, helping us arrange these speakers. And I don't know if you all may have caught on to it. You all are very smart people, but the lineup, we start at the sun and we work our way out into the solar system. That's why we chose that path. So a little trivia there, but yeah, look forward to seeing you all. Thank you.
All right, thanks. Thank you, Gordon. All right. All right, so our final speaker is our own Mr. Dave Falkner. He's going to be talking about Stonehenge. So
I'm well, absolutely lengthy. I'm Dave Falkner. I've been a member for a while. I do a lot of stuff. So we'll just leave it at that. And I appreciate you coming tonight and everybody online. Tonight, let's see. Here we go. Oh, it's lags a little bit. I'm going to talk about Stonehenge, history and mystery. Okay. Start up by saying that last September, my wife and I decided that we wanted to go on a little vacation, and we'd never been to London. And it's a very historic place, and so we made a trip over to London and took 2 or 3 excursions, one of which went to Windsor Castle, which is an amazing place as well, Oxford, and Stonehenge. And when I went to Stonehenge, I'd heard of Stonehenge. How many people have heard of Stonehenge? Raise your hand. Yeah, just about everybody. Okay, how many have been to Stonehenge? A fair amount. Okay, that's good. That's good. So when I went to Stonehenge and I saw this huge monument rising out of the pastoral landscape there of England, it's pretty impressive. And when I learned about when it was made and who made it, I became really fascinated with it. So that's what we're going to talk about tonight. The site is run by a group called the British Heritage Foundation, which runs a number of historical sites for the British Crown. Okay. And so my information, a large amount of the information comes from their website and their book. Many of the images come from there as well. So that's where I got my information. You should note that, and you will see that this is a prehistoric site, meaning that there's no written records about what happened at Stonehenge. Okay, so everything that they've been able to put together is basically educated guesses, I guess, if you want to put it that way, of over 100 years of archaeological investigation and dating. And so, but they've put together things, what they feel is pretty close to what happened at Stonehenge. Okay. Stonehenge is located west of London. You see on the left-hand map here, you can see down the bottom right, the kind of the beige colored London there, and you go like due west of that. And then the other map is a kind of a blow up of that section. You can see in the little inset what that section is. And then the red star is where Stonehenge is located. And you're driving along, and again, it's very pastoral. There's like rolling hills. You have grazing land. There's sheep herds, a few crops out there, and then all of a sudden you see this huge stone monument rising out of the fields there. So it's Stonehenge. Okay, it is first and foremost a henge. Now, I wasn't real familiar with what a henge is, and I don't know if you are either, but they have a number of them around the British Isles and Northern Europe. And it's basically a round plot of land surrounded by a ditch. And then on the outside of the ditch, there's an earthworks mound. Okay. And then there's usually one or more accesses to the inner part where there were rituals or ceremonies that were conducted. Okay. Generally, they're fairly good size, usually 60 feet or larger in diameter. Okay. And they may have some things in them, like some stone markers like you see here, and others like this one here, they have some wooden posts sticking out. In fact, this is probably the second most popular place in England. This is Woodhenge. Okay. Again, another henge, and you can see coming in from the bottom right there, that's the access into the center part of the Woodhenge. Okay. And like I said, they were used primarily for rituals and ceremonies and astronomy. There's some astronomy there, very, very limited. Okay. These were not observatories, okay, at all. Okay, so what makes Stonehenge unique, though? Okay, well, first of all, Stonehenge, the ditch goes around like a normal henge, except that the earthworks mound is on the inside instead of the outside. In fact, purists state, well, this isn't a true henge. Earthworks mound's on the wrong side. Well, I think it's splitting hairs. Okay, it's basically a ditch with the earthworks mound. And then, of course, it's this huge stone monument in the center of it. No other henge has that huge stone monument. Okay. Okay. So at a 50,000 foot level, Stonehenge consists of this ditch that goes all the way around it. It was and the earthworks mound that goes with that. It was started 3000 BC, so over 2,500 years, excuse me, 5,000 years ago. It's about 330 feet in diameter, so it's pretty good size. Okay. The main access to it is in the northeast part of it. There is another smaller access to the south, and it consists of an outer circle of sarsen stones. Okay, I don't know. Can you see my arrow there or not? Yeah, I can. Okay, so you see on the outside, these are sarsen stones here, as well as the inner horseshoe. We're going to talk about all of these. Okay, the inner horseshoe are called trilithons. And then there's bluestone settings as well. The bluestones play an important part of this as well. And then there's some other stones in the avenue. And we'll talk about the alignment of Stonehenge, because it is certainly aligned to the solstices. Okay. Now, scientists believe that it was built in basically 3 phases. And phase 1 was about 3000 BC. Okay. Started as a typical henge. And so they built this ditch, 330-foot diameter ditch, about 20 feet wide and 4 to 7 feet deep, all the way around. Now, mind you, these are people who had very primitive tools, right? It just amazes me that they could even do that with what they had available to them. Okay, we'll talk about that a little bit. Once you get below the surface of the ground there, you get into chalk. Like white chalk, like you use on chalkboards. Okay, so as they dug in and piled up the earthworks mound, that you would have, from a distance, seen this white circle with the ditch and this white earthworks mound all the way around too, from the chalk. Okay, and when scientists went and started, excavating this and looking into what they found in the ditch were a large number of animal bones, but they also found the cremated remains of humans. Okay. In the ditch, as well as in the earthworks mound. Okay, they estimate there's probably 150 people buried there in the ditch in the earthworks mound. Okay, they believe that there were, the rituals were held at Stonehenge, and that the cremated remains were buried there. And we're going to find that there's also these holes called Aubrey holes. We'll talk about those in just a minute. And there are cremated remains at the bottom of that as well. So it was basically a cremation cemetery at first. Okay. These are the tools they had to work with, right? We're talking stone axes. We're talking mandible bones for digging and antler horns for scraping the surface. And then they just shoved it out with their hands, I guess. I mean, this is really primitive. It took them a long time to build a ditch 20 feet wide, 4 to 7 feet deep, and 330 feet in diameter. Okay. On the bottom right are some sarsen hammerstones. We'll talk a little more about those later. Now, I mentioned the Aubrey hole. So you have the ditch going around and the earthworks mound, and inside the earthworks mound are all these holes. They're called Aubrey holes because a guy by the name of John Aubrey discovered them originally in the 17th century. And then later on in the 1920s, they were further investigated by Colonel William Hawley. Okay, and these are spaced about 5 to 6 meters apart. They're about a meter in diameter, about a meter deep. And what they found at the bottom were cremated remains of humans. They estimate about 60 humans were probably buried in these Aubrey holes. Okay. And this is clearly a cremation cemetery in 3000 BC. Okay. Now, along with that, in the northeast part where that gap is, it goes out. There's a stone there. Okay, it's kind of unfinished and standing up. Was probably a stone that existed there that they stood up, but it's a line so that the stone itself and the center of the henge align so that in the winter at the winter solstice the sun sets right by that stone. Okay, and likewise in the summertime at the summer solstice, if you stand look the other way, the sun rises right by that stone. So it was clearly aligned to the solstices. Okay, so it's called the heel stone or the friar's heel. Okay, so that was 3000. About 500 years later, 2500 BC, phase 2 starts, and this is where we start seeing these huge stones being moved. Okay, and the Sarsen stone are the hard silicon rock stones, the uprights and the lintels there that go around the circle there in the outer circle, as well as the horseshoe on the inside. We'll talk a little more about those. And then the blue stones are the smaller stones. There's they started out as a double row of those that go around the inside. That's about 100-foot diameter, okay, of the Sarsen stones. The blue stones inside of it. Those are much smaller. And then we have a smattering of other stones too, like the altar stone and station stones. We'll discuss all those. And then you see off to the northeast there, outside of that opening in the ditch there, you see the heel stone out there. Okay. Transporting the stones. So the stones weren't just sitting around us. It's the Salisbury Plains where this is built. Okay. And the stones weren't just sitting out there. They actually went and transported these stones to the site. Okay, these huge Sarsen stones were transported from a place about 20 miles to the north called Marlborough Downs there, and it's about 20 miles away. And they transported those stones up there. The other stones, the blue stones, actually came from a place called the Preseli Hills, which are way in western Wales. They're out there, the Preseli Hills. Okay, and they were transported, but that's about 150 miles away. Okay, and then there's the altar stone, which they originally thought came from South Wales, but I have late breaking news here, which I will tell you about when we get to the altar stone. Okay, so the Sarsen stone circle. Okay, so these are the Sarsen stones. These are huge stones. All right, here's a gentleman standing next to it, and they were used to create the outer ring and the lintels, as well as the inner horseshoe of trilithons, which I'll talk about in a minute. These stones were 13 feet high, 7 feet wide, about 3.5 feet thick, and weighed about 30 tons each. Okay, mind you, they didn't have anything. They didn't have any cranes or anything like that. They had to get these stones from Marlborough Downs and drag them somehow up to the Stonehenge site. Okay. The lintel stones were a little bit smaller. They're only about 10 tons each, and they were lifted up and put on top somehow. We'll talk about theories about how that was done. Okay. How did they transport these? Well, there's a variety of ways they could have done it. They maybe used all of these at one time or another. Okay. Ones are sleds and rollers. Okay. So there's a group, I'll talk about it in just a minute, that actually experimented with this to see if it could be done. But you can see here where they used the trees and they rolled the stone along the trees there. And then as they got one free, they pulled it to the front and just kind of did one of these, one after the other to roll it along. Okay. They used ropes for that, probably plant fiber ropes. Okay. And They use some mechanical advantage, some levers. We'll talk about that in a minute too, how they might have used levers for this. They may have greased tracks with animal fat, okay? And they may have transported some of these in the winter when there was snow out there, and it would have been a little bit slippier with snow and all. But it took probably about 200 men per rock, and scientists estimate it would take at least 12 days to transport one stone from Marlborough Downs up to the Stonehenge site. Okay. Now, a group called the Monolith Moving Experiment got out there and they tested some of these methods, and they were successful in moving these monoliths by various means. One being the rollers here, okay, and then and this is what one of those stones looks like. This is at the visitor center. This is a shot I took at the visitor center, and you see how huge it is. Please note on the right side that's the top of it, and there's a little mound there, a little canyon there. That plays a part too. And then the bottom of it's smooth too. We'll talk about that a little bit. But this is one of them right here that they hauled all the way up. Okay. Now they might have also used levers, particularly when you talk about a hill or something. So they did an experiment on this too that seemed to work. You do a bunch of long poles that give you a big mechanical advantage, and get a bunch of guys out at the end of each pole, and you push down on the lever to lift up the rock. And then if you get all those guys moving in one direction, the stone would move in the other direction. Not far, but it would move a little bit. And then you just reset it, do it again. Okay. And that's another way they could have moved the stones. Okay. Now, once you get to the site, now you got to get the stone upright. So how do you do that? Well, they figured that they dug a hole for the stone there, and they also dug a kind of an inclined plane, a ramp, if you would. And then they would be able to move the stone out to the point where you got kind of a critical point where the stone would tip. You could add rocks out to the end there to help it tip a little bit, and it would tip up and slide down into that hole. And then they make an A-frame, okay, out of trees, and a rope, give it mechanical advantage to tip the stone upright and then backfill behind it to keep it in place. And yes, they even experimented with that and were very successful in doing that. So that's the way they think that they probably got these stones upright. Okay. Now you got to get these lentils up on top of these huge sarsen stones, right? One way that they think they probably did it was to build scaffolding around the stones and then put the lentil stone there, and using levers, they would lift it up, put some boards underneath it to hold it, then build up the scaffolding a little bit, then take levers, lift it up another one, put a bunch of boards underneath it, so on and so forth until it got to the top, and then they'd lever it over and put it on top. Okay, that's one theory. Another theory that was tested was actually just using an inclined plane made out of posts, wooden trees, and just through brute force drag it up and set it on top. Okay. Now, these people didn't have really sophisticated tools, but one thing they did have is they were pretty smart, because on the top they actually show where they had these tendons and mortise holes, so that when the lentil got up there, they set it down and got locked into place. Okay, so it wouldn't move. That's pretty ingenious. Okay. All right. There were a total of 75 sarsen stones that were needed. 60 formed the outer ring. Okay. That was 30 sarsen stones upright, spaced about 5.5 feet or so apart. And then the lentils, 30 lentils going across the top of it all the way around. And then the remaining 15 stones made up the horseshoe of the trilithons. We'll talk about that in a minute. Okay. The stones seem to be shaped. Not only the top there that had the little tendrils and mortise holes, but even the face of these stones on the inside looked like it was also shaped and finished off, so to make it look kind of nice. Okay, so on the inside, and they used these tools for that: stone tools, stone hammers, stone flints, to try and get the interface done. Okay. So this is an amazing amount of work that was being done on this. Okay, now the inner horseshoe of trilithon. So a trilithon is basically two upright sarsen stones with a lintel stone across the whole thing. Now instead of locking things together, you just have it across the whole thing there. And there's 5 of them. They're horseshoe shaped with the opening toward the northeast where that heel stone was, right? And that opening coming in. We'll talk about more about that opening. And it started out that these are actually larger than the ring of sarsen stones. The pair that's closest to the opening was about 19 feet in height. The next pair were about 23 feet in height, and then what they call the great trilithon was in the back. It was about 26 feet high. Okay, these stones were weighing in the neighborhood of 45 tons. Okay, so these are huge stones. Okay, now some of the trilithons are still standing. The great trilithon has fallen over, but the altar stone was placed right in front of the great trilithon. Now, so here's this picture of the altar stone. You can see it flat there, and there's the fallen trilithon over the stone. I mentioned the late breaking news. Literally came out a week and a half ago. Okay, so it says, recent geochemical analysis has confirmed that the Stonehenge's central altar stone originated from northeast Scotland, 440 miles away. Okay? Specifically, the Arcadian Basin, rather than Wales as previously believed. The discovery, published in the journal Nature, indicates that this 6-ton monolith was transported at least 466 miles to the site in southern England. Researchers used uranium-lead dating on zircon, rutile, and apatite crystals within the sandstone. The ages of these mineral grains perfectly match the old red sandstone of the Arcadian Basin. Given the massive weight and the topographical barriers of the British landscape, experts suggest the stone was likely transported via marine shipping route along the coast rather than overland. This finding implies a far more advanced level of societal organization and long-distance trade networks in Neolithic Britain than archaeologists previously assumed. Woo! That's a lot. So now we have the altar stone that brought in from 440 miles away. All right. The bluestones. Okay, so the bluestones are much smaller, 3 to 5 tons roughly. There were about 60 of them that were brought in from the Priscilla Hills. Okay. Now, it's a very hard igneous rock. Okay. It's called spotted dolerite. And it's interesting because it's got little cavities inside of it, such that when you strike this rock, it actually kind of rings a little bit. I saw a YouTube video on this. The guy's hitting the rock, and I tell you what it sounds like. If you've ever had a pipe, a metal pipe, a long metal pipe, and you hit the end of it, and it makes that kind of that sound, that's kind of what it sounds like. Okay, so the folklore says that these bluestones have healing properties to them. So it may be why they thought, okay, well, we're going to bring the bluestones over to put into our ritual monument here. Okay, and so they brought these stones over and lined the inside the sarsen ring with bluestones. Okay, didn't finish them off at all, just kind of set them there upright along there. Okay, so they are sourced from Priscilla Hills over there in western Wales. They either transported them overland, okay, to Stonehenge, or it's possible, since we just talked about the one from Scotland, that they may have used a marine route and brought it up the Avon River, which gets pretty close to Stonehenge. Most scientists believe they probably just carried it. The reason is if you get a platform and you got enough guys with poles there, you can load this thing onto a platform and just lift it up and just carry it. Okay, so that's how they believe that the bluestones got over to Stonehenge. Okay, so the outer circle bluestones were not shaped, and they originally arranged in a double row there. around the outside. Okay. Now there's station stones that they found there. And the station stones, you can see the 4 station stones to the top right and bottom, top left and bottom right. Okay. They form a rectangle. Okay. The rectangle happens to be pretty close to perpendicular to the line of the solstices. But more importantly, if you draw a diagonal from the vertices across on both sides, where they cross is the exact center of the hinge. And so they think that this was used as surveyor markers for when they were building Stonehenge. Make sure that was right in the center of the hinge. Okay. Then there's the slaughter stone. So this stone is just lying on the ground. It's near the entrance. You can see it on the right side there. It's near the entrance into the hinge there. And when it rains, the rain kind of collects in the dimples of that rock and leaches out some of the iron ore that's in there. And so when it dries, it's kind of orangish. Okay. Well, in the Victorian era, they were looking at this. They misinterpreted that as being blood stains, and so they thought this was used to slaughter animals or, God forbid, humans. And so that got the name the slaughter stone. But later they realized that that wasn't really the case. Nevertheless, it's got its name, so that's what it is. Okay. Then, there's evidence in about 2300 to 2200 BC. This is phase 3. And this is where some of the stones were rearranged. Okay. Most notably the blue stones. So what they did was they took the double ring of blue stones and they brought some of those to the inner ring of trilithons and left a single ring of blue stones on the outside. And then originally maybe an oval, but later on, it was just a horseshoe that kind of conformed to the inner side of the trilithon horseshoe. And those were actually shaped. We'll see in a minute. Some of those stones were shaped. Okay. On the left here is one of the blue stones. You can see clearly it was shaped and formed. And there's many of the blue stones on the inside of the horseshoe that are like that. Okay. So they were shaped and all that. Now, later on, they did discover that there were some etchings in the sarsen stone, but the etchings themselves appear to be more recent than the original building of the Stonehenge. The tools there you see, this is the beginning of the Bronze Age, which is around 1750 BC, so it's a little bit later. And these is a dagger at the top and a axe blade at the bottom, and they could see impressions of that in the sarsen stones. And I found about 150 of those carved into the sarsen stone. Don't know the meaning of them, except that there were some carvings there, but they were much later than the original building of Stonehenge. Now, along with the structure itself, there are some other things that are interesting. One is the avenue. Okay, so if you see here you can actually see the avenue coming out there. That stone by that road there, which where we came in, that's the heel stone, and the avenue comes out and and kind of curves around. So you can see on the right there, here's Stonehenge, and the avenue comes out, curves around like this, curves around this, goes all the way down to the River Avon there. Okay, it's about 1.5 miles long, and about 100 feet wide or so. And what they believe is that that had a ditch with the earth mound along the ditch, pretty typical of that time. And they believe that this was used as a place that people would approach Stonehenge. So it was this kind of ceremonial approach to the entrance to Stonehenge. Okay. Now, what about the people of Stonehenge here? Okay. Well, they think that about 4000 BC, that the peoples of England were probably nomadic. They were looking for food, searching for animals and things of that sort. But around 4000 BC, there's evidence that there was a migration of some people from Europe to England and bringing with them agricultural techniques as well as domesticated animals. And so with that, they began to set up in more permanent settlements at that point. One of the settlements would have been near Stonehenge, and they would have had to have that in order to be able to support the work that was being done in transporting all those stones and all that stuff. So The houses, this is again on the left, that's from the visitor center. They believe these are the houses that they would have had there. The bottom part's kind of a stone, and then the top is grass, and there's another one that's all grass. Okay, so these are types of structures that they would live in. Okay, and on the right is a kind of a sampling of all the food that they believe was available to them at that time. There's honey, pigs and boars. There's apples, mushrooms, leafy vegetables, cheese, nuts, and so forth, so that they would have had an abundant amount of food. They would have obviously had to store some of this food over the winter to survive that. The people in Northern Europe and prior to about 4000 BC buried the remains of their people in what are called long barrows. This is about 250 feet long, about 80 feet wide. It has catacombs inside it. So, so this is a community burial site. There'd be lots of people buried in here, and they would have one or more entrances. You can see here near the bottom of that one, there's an entrance that goes into that one and goes back into it. Okay, and so these long barrows were what was originally used to bury some of the dead. Okay. Later on, they would use smaller ones, just called barrows. But before I talk about the barrows, there's this other interesting artifact. It's a rectangular piece with a ditch and the earthworks mound that stretches about 1.7 miles, about 330 feet wide. Originally, they thought that when the Romans came into England, that they built this for chariot races and the like. But later on, archaeological digs came to realize that this was actually built much before that, is much older than that. And so they think it may have just been used for ceremonies and the like. On the right are the barrows, okay? These are round barrows or just barrows, okay? They don't hold nearly as many people, maybe one to just a few people. And they're kind of different designs. In the bottom left, you see they all have a ditch around them. That was the thing. They put a ditch around them, and then they bury a person. Usually had some artifacts that were important to that person. Maybe some sort of arrowhead or jewelry or pottery or something like that. And they would be buried in the barrow, and it was like that. Sometimes they would add people to the barrow and build it a little bit larger. Okay, there's a straight round barrow there. You see in the bottom left, and the top right, you see a barrow where you got a ditch and that's kind of flat, and then you got the barrow. So kind of different designs of these barrows, and you wouldn't even have noticed them until somebody pointed out, that's a barrow, okay? And then all of a sudden, these things are everywhere. Okay, so this is at Stonehenge. I just took a picture from Stonehenge. Oh, yeah. So what do we got? We got an arrow here. We got a barrow 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 here. These things are everywhere. Okay, right? And they're basically burial sites. Okay. In fact, they did a survey of all the barrows that are contained around Stonehenge, and they found that there were some 300 barrows around Stonehenge. Okay. And Stonehenge is one of the red markers with the black dot there. That's Stonehenge. And all these barrows that are around Stonehenge. So that's just that area. So now I'd like to tell you that Stonehenge was an ancient astronomical observatory where they made detailed measurements of the sun's movement, the moon's movement, the equinoxes, the planets. It's not true. Scientists have gone in there, they've studied the orientation of the sun and all that. This is primarily a monument that is aligned to the solstices. The solstices were the important thing for these people, right? They're agrarian people. So, when it got to being cold in the fall and things started going dormant on them, they had their food supply. They hoped it would last throughout the winter. They couldn't wait for spring to come. So marking the lowest point in the sky for the sun at the winter solstice was real important to them. And then they celebrated that time, knowing that after that, the sun would start getting higher and higher in the sky, and pretty soon they'd be able to, get out there and grow their crops and so on and so forth again. And during the summer, I'm sure at the summer solstice, they knew that it was going to start getting, shorter. So they celebrated, hey, we made it halfway through the summer, right? So they had these things. But that is the astronomical importance of Stonehenge. Okay. And it's marked here on the walkway to show exactly where it's lined up for the winter and the summer solstice. Okay. And today, they still celebrate it. Okay. This is on the left is winter solstice, and the right is the summer solstice, and they have thousands of people who come out, and many are dressed in costume to celebrate the winter solstice, right, and the summer solstice. Okay. It's about the only time that they're going to be able to get close to that monument, because most of the year, including when I was there, they have they roped off about 100 feet from the structure, because in the past they've had vandalism, so they keep people away from the structure itself. But you can certainly see it very easily. I mean, pretty big. So, all right. Now, before I take questions, though, I call this history and mystery. Okay. Yeah, there's a lot of mystery about, how they moved the stones up and all that. They kind of figured that out. But there's some mysteries here that have never been answered and probably will never get answered. Probably the biggest one is, why? Why build this thing where they did? Why not build it closer to Marlborough where the stones were? Why do I drag them 20 miles to get to their site there? What was so important about this particular site in the Salisbury Plain that they felt they needed to build this huge stone monument there? Only one in Europe, only one in the world as far as I know. Okay. And as aligned to the solstices, we kind of understand that. But, why use the sarsen stones? Why use the Perselli, the blue stones? Kind of check, say that probably has to do with the healing properties. Why drag a stone from Scotland 400 miles down for their altar stone? Okay. All that's a mystery, and we probably will never know why they did what they did. But boy, they did an amazing job here considering, what they had to work with. Okay, I'll take questions now if I can.
Anyone, questions? Okay. Bill.
Was any of it reconstructed, or was it all kind of found intact or more or less intact?
No, it was not found intact. It had fallen down in disarray. And they did a fair amount of work in the 20s and 30s to erect some of the stones and put them in place. In fact, some of them are actually in cement now, which people are not real happy about. They'd rather have it just the way it was. But at least you could see the original construction. And obviously, they didn't have all the stones either, because they couldn't reconstruct the entire thing, but they could reconstruct most of it to understand how, what the nature of it was.
I got a question. If it's pointing to the equinoxes, the sun at equinoxes, we all know that there's precession, and this thing was built thousands of years ago. So you would think that the sky's been a little bit different, and it's moving back and forth. Maybe this is just lucky, and it just happens to be that way right now.
I thought about that. I really have. I don't know how to answer that, other than that at the equinoxes, not the equinoxes, but at the solstices, where it's a particular alignment of the Earth tilted toward the sun. Whether it's up in that, I don't know. Apparently it's close enough that it stays either next to or behind the rock the whole time.
Okay. Okay.
What was that? I didn't hear that. The timing of the rising would be effective, and not where it rises. Yeah. Okay. I'll buy that. Okay. Any other questions? Yeah. Oh, right over here first. Okay.
Could this and other henges just be glorified barrows?
Be built by pharaohs?
Be glorified barrows.
Oh, glorified barrows. There was one mound in there that looked like a barrow, but when they got into it, there wasn't anything in it. Okay. So I don't think they're glorified barrows. I think they're ritual, ceremonial places where they honored the dead, maybe cremated them, and then transported the ashes to the barrows to keep the actual henge itself pristine, if you would, for ceremonial things. But I don't know. It's a mystery, right? Yeah. Don had a question back there.
So have they ever taken a crane and lifted them up to see if they have the, the mortar pinion and they do?
They did that when they reconstructed it in the 20s and 30s. They used cranes to lift them up and fit them on there, and they fitted right on there just the way they're supposed to. Yeah. Yeah. Over here.
It is frustratingly close to but not right on, as you said. I'm just wondering how many, do you have the number? Like how many degrees do they miss the sunrise location by?
It goes, let me go back. It's gonna be a way, not too far. Here, this is good. So you see the right side of that? That's where the sun sets, is right next to that, not directly behind the stone, but right next to it.
It just seems like so much effort. How did they miss it? Or you think that was? Yeah. Yeah, maybe, yeah. Was that on purpose?
Yeah. Oh, yeah.
It's on purpose to be next to the rock, not on the rock.
I think so.
Okay.
I think so. So they could actually watch the sunset. See, otherwise it would go behind the rock. You couldn't actually see the sunset. Right?
Makes sense.
Right.
So what happened to all of the astronomical theories that were prevalent in the 70s and 80s? Have they just all got away?
It's a mystery. No, I don't know about the astronomical theories. I mean, I've read through that there's a booklet that they give out, and they talk about the astronomical things, and they talk about the fact that they look at the equinoxes and moon cycles and things of that sort. And there didn't seem to be any particular arrangement that that rocks were in that would indicate that they had more than this as the astronomical alignment. Yeah. Hang on. Let's get the microphone here.
Have you been to any archaeoastronomical sites in the U.S.?
I have not. I'd love to go down to the southwestern United States because there's a number of them down there that really are. Chocolate Canyon, yeah. And I know about those. In fact, I got a book on those that that looks really interesting. Those really are astronomical sites, and so that would be interesting to go to for sure.
Yep.
Yeah. What about the idea that it's a marketplace for trade and even now medicine's a big part of our economy. Maybe this tells people when to all show up at the same time. What do you think?
Again, that's possible. There's no written records as what this is actually used for. So they're speculating a little bit based on one of the things was the folklore about the bluestones. Okay, the bluestones had a healing property to them. Could it have been a marketplace too? I don't know. Maybe. I mean, the temple was in Jerusalem, so I mean, you could have this as a marketplace as well. It would certainly be someplace that would be, pretty easy to find. So, this big thing rising up out of the farmlands there.
Are there any questions online? Nothing. Anything else?
Deep were they buried? For those big ones?
Yeah, those big ones look like they're buried about 6 or 8 feet deep. Yeah, they're not. I mean, they can fall over. So I mean, they're not real deep, but so yeah.
So when you're there, are you able to go down to the river site and look at the stones there?
I didn't
Is that
do
part
that.
of their tour or?
That's not. No, that wasn't part of the tour. That's interesting. I hadn't thought about seeing. Well, I didn't even really know much about the avenue until I started doing the research on it. So I don't know whether you're restricted from doing that or not.
I don't think it's part of the actual
No, it's
site. I remember
not.
the visitor center, then that path that goes around like 100 feet from the actual monument.
Right.
And you have to stay on that path, so.
Yeah. Oh, is that right? Yeah.
I don't really have a question, but a comment, and that is that number one, how could they build a watercraft that would be stable enough and sturdy enough to haul a 6-ton rock 5,000 years ago? And not only that, but I mean, I have questioned all of these sites and wonder if the true age is really known. There's evidence.
Well, so with regards to the age, they did carbon dating and all these scientific methods to date the stuff. So they know how old they are. Well, they did some sort of dating to the Sarsen rock in order to determine that it came up there. So, and all of the bones and things were all carbon dated, I would imagine. So they use scientific methods. They didn't just, pull it out of the air. So.
But it is a mystery.
But it is a mystery. I won't deny that.
All right, any other questions? All right, thank you, Dave.
Here.
All right, we have come to the end. We skipped a lot of the normal slides, so I did hear that Jesse scheduled reserved some tables at the pizza place. 9:30. So we have a little
Pizza
bit
Luce?
Pizza Luce. Yeah. So next month, right here, same time, same channel, same place, same bat channel, everything. Our scheduled speaker will be Chuck Allen from the AL. So he always does a good talk. And again, I don't know. I don't know. He was last year. So, yep. So anyway, thank you for coming, and look for the happenings online for the latest things. And if you haven't seen a Slack and a forum post, we do have premiere tickets to Hail Mary. If you're interested in seeing it, I believe it's next Monday. It's that Monday, the February 16th. In the Roseville Theater. So there was a limited number of tickets. There's links on the website. They're specially for MAS. And so it's first come, first serve. So if you snooze, you lose. And so let's go see a movie. Yes, it'll be better than the last one. All right. Thanks, everybody.